Everyone thinks Oumuamua is an alien spacecraft, a cigar-shaped probe from another star system sent to study us. It accelerates without visible exhaust. It tumbles chaotically. It passes Earth and just leaves. It's the perfect alien reconnaissance mission. Except it's not. The truth is simpler and way more interesting. Because the explanation for Oumuamua's behavior doesn't require advanced alien technology. It doesn't require anything exotic at all. It requires something we see in our own solar system every single day. Something so obvious that nobody thought to look there. In the next few minutes, you're going to understand exactly what Oumuamua is. You're going to see why the alien hypothesis falls apart. And you're going to realize that the real universe is far stranger than any science fiction. Let's start with what made this object so weird in the first place. Here's what made Oumuamua so strange in the first place. When we detected it in 2017, it was already leaving the solar system at 87 kilometers per second. That's a hyperbolic trajectory, meaning it was moving way too fast for the sun's gravity to capture it. Everything in our solar system orbits the sun because we're all trapped by its gravity. To escape from Earth's orbit, you'd need to reach about 42 kilometers per second. Oumuamua was doing twice that speed. But here's where it gets interesting. Oumuamua passed inside Mercury's orbit, incredibly close to the Sun. That close encounter with such a powerful gravitational force should have slowed it down. Instead, as we tracked the object moving away from the Sun, it accelerated. Something was pushing it and faster. This is where most people get stuck. Comets accelerate all the time because they're made of ice. When they get close to the Sun, the ice sublimates, transforms directly from solid to gas, and that outgassing creates thrust like a rocket engine. That's normal physics. But Oumuamua showed no visible coma, no tail, no dust cloud. It looked like a rock, yet it was accelerating like a comet. That's the contradiction that triggered the alien speculation. Then there's the shape. When we observe distant objects, all we see is reflected sunlight. Most asteroids are roughly spherical, so their brightness stays relatively constant. Oumuamua's brightness pulsed dramatically every 7 hours, cycling from bright to dim and back again. This pattern told us the object wasn't round. It had to be elongated, either cigar-shaped or pancake-shaped, tumbling end over end through space. The dimensions we calculated were extreme. Somewhere between 100 and 400 meters long, but only about 40 meters wide. That's a length-to-width ratio we've never seen in any natural asteroid. Add the high reflectivity, which suggested a surface made of something shiny rather than dark rock, and you've got an object that doesn't fit our normal categories. So here's the situation that triggered the alien hypothesis. An elongated, highly reflective object from another star system passes through our solar system, accelerates without visible exhaust, tumbles chaotically, and then disappears back into interstellar space. If you were designing a probe to study other solar systems, you might build something that looks exactly like that. The logic seems airtight. But there's one critical error in that reasoning. One assumption that everyone makes without realizing it. And once you see it, the entire mystery unravels. The error is assuming all outgassing must be visible. That assumption is wrong. Not all gases create visible tails. Some are completely transparent and colorless. Once you understand that fact, the entire alien hypothesis falls apart. The acceleration mystery has a simple explanation that doesn't require extraterrestrial technology. The answer isn't what most people expect. It's not a comet, it's not a rock, it's something we see in our own solar system, but nobody thinks to look there for the answer. Nitrogen ice. Not all outgassing is visible. Here's the thing most people don't realize about gases. Not all of them leave a trail. In fact, the most common gas in Earth's atmosphere is completely invisible. And there's a dwarf planet in our solar system made almost entirely of it. Nitrogen is colorless and odorless. When nitrogen ice sublimates, it doesn't create a visible tail or coma. It just releases transparent gas that we can't see with telescopes. But that invisible gas still creates thrust. Think of it like the cloaking device in Star Trek. You can't see the ship, but the propulsion system is still working. The physics works exactly the same way as a water ice comet, except there's no visual signature. We have a perfect example of nitrogen ice in our own solar system. Pluto. The surface of Pluto is made almost entirely of frozen nitrogen, which has extremely high reflectivity. We call that high albedo. For years, that brightness made astronomers think Pluto was much larger than it actually is. Turns out, Pluto is only about 2,400 kilometers across, smaller than our Moon. But it looks massive through telescopes because nitrogen ice reflects so much sunlight. If Pluto's reflective surface fooled us, an object from another star system could definitely fool us too. Now, imagine this scenario. A dwarf planet in another star system, similar to Pluto, gets hit by a massive asteroid or experiences a collision with another planetary body. Think of the catastrophic impacts in Deep Impact or Armageddon, but happening in another star system billions of years ago. The impact shatters the dwarf planet and ejects chunks of frozen nitrogen into space. One of those chunks gets flung outward with enough velocity to escape that star system entirely. It spends millions of years traveling through the void of interstellar space, frozen solid, tumbling slowly. Eventually, that nitrogen iceberg enters our solar system. As it approaches the sun, solar radiation begins heating the surface. The nitrogen ice starts to sublimate, releasing invisible gas. The outgassing creates thrust, accelerating the object. The closer it gets to the sun, the more nitrogen sublimates, and the stronger the thrust becomes. By the time it passes the sun and heads back out toward interstellar space, it's moving faster than when it arrived. This explains both the acceleration and the high reflectivity. The elongated shape makes sense too. When a planetary body shatters, the fragments aren't going to be spherical. They'll be irregular chunks, potentially very elongated depending on how the impact fractures the ice. The tumbling motion is exactly what you'd expect from an object that was violently ejected from a collision. This scenario is far more plausible than an alien probe. Nitrogen ice exists. Dwarf planets exist. Collisions happen. Objects get ejected from planetary systems. Every step in this explanation relies on physics and chemistry we've already observed and verified. There's nothing speculative about it. But let's not just accept the nitrogen ice explanation because it's plausible. Let's actually test it against the alien hypothesis. Because if Oumuamua really were a spacecraft, there are specific behaviors we'd expect to see. And Oumuamua doesn't match any of them. Compare that to the alien hypothesis. For Oumuamua to be an alien spacecraft, you'd need an advanced civilization that built a probe, sent it on a million-year journey across interstellar space, programmed it to accelerate using some propulsion system that leaves no detectable signature, and designed it to tumble chaotically for no apparent reason. Then this probe passes within 24 million kilometers of Earth and just leaves without making contact, without changing course, without transmitting any signals we can detect. The probabilities don't favor the alien explanation. Occam's razor applies here. The simplest explanation that fits all the observed data is that Oumuamua is a chunk of nitrogen ice from another star system. That's not speculation. That's the most logical conclusion based on the evidence. If Oumuamua were actually an alien probe, there's one thing that doesn't add up. One behavior that no advanced civilization would ever design into a spacecraft. And once you see it, the alien hypothesis falls apart completely. Why would an advanced spacecraft tumble chaotically through space? Tumbling wastes energy and makes navigation difficult. Any civilization capable of interstellar travel would design a probe with attitude control. Why pass Earth at 24 million kilometers and then just leave? In every alien contact movie, from Arrival to Independence Day, the probe either makes contact, transmits signals, or adjusts course for closer observation. That's what reconnaissance looks like. Oumuamua did none of that. If the goal was reconnaissance, why not adjust course for a closer flyby? We detected no signals, no course corrections, no observable technology of any kind. An advanced civilization wouldn't design a probe to tumble, wouldn't pass Earth without investigating, and wouldn't leave zero detectable signals. The alien hypothesis contradicts basic logic about how any reconnaissance mission would actually work. But here's what changed everything. In 2019, we detected Borisov, another interstellar object. In 2025, we spotted 3 I-Atlas, a third visitor. Oumuamua stopped being a one-of-a-kind mystery. It became evidence of a pattern. The universe is full of ejected debris from the planetary systems. What seemed impossible in 2017 is now ordinary physics. Oumuamua wasn't an alien probe. It was a messenger, one of countless cosmic wanderers drifting through the galaxy. So here's the real story of Oumuamua. It's not aliens, it's a nitrogen iceberg from another star system. And the fact that we can explain it with physics we already understand. That's not boring. That's beautiful. That's the power of science, taking something that seems impossible and revealing the elegant truth underneath. Your audience is different. You don't want hype. You don't want mystery for mystery's sake. You want to understand the universe as it actually is, not as Hollywood imagines it. And that's exactly what we do here. We take the myths everyone believes and show you the real science, because truth is always more interesting than fiction. If this changed how you see Oumuamua, hit the like button. It helps us reach more people who value accuracy over sensationalism. Subscribe for weekly deep dives into the space myths everyone gets wrong. And here's a hint for next week. We're tackling the biggest misconception about black holes. Spoiler, they're not cosmic vacuum cleaners. What space myth should we tackle next? Drop it in the comments. Your suggestions shape what we cover, and I read every single one.